Hello and welcome to JS's Do's and Don'ts. My name is Jens. Today I'd like to talk a little bit about SLA desktop machines like this Form 1 Plus here by Formlabs. First, before I get into some details and basics which are important to know about this machine before you get started, the term 3D printer is actually not the correct term. These machines technically are not printers. So it's a little bit strange to me that the manufacturing companies still use that term, or have even started using that term to make everybody else think, oh yeah, this is a printer. It is not. Technically, this machine cures resin. That's what it does. It doesn't print anything. Same with the FDM machines, the glue gun machines with the nylon spools. People call those extrusion printers. First of all, again, they're not printers. And secondly, they don't extrude anything. An extrusion is a physical force. If you have a piece of metal and a die and it punches into the metal and pushes out the shape, that's an extrusion. Your FDM machine is a dispenser. It's a dispensing machine. It dispenses, just like a glue gun, molten plastic or nylon. So maybe us users eventually can straighten it out again and correct that, not using the term printer. I'm sure it's going to be difficult because most of us are so used to it and probably don't care. Who cares? But I think it would be kind of silly knowing that it's wrong and still using it. Doesn't really make a whole lot of sense. Okay, so much for that. Now getting back to the machine here, it has a certain technology which all SLA desktop machines are using. And it's basically, let me open up the machine here. You have a building platform which is attached to the top, and a tank which is sitting in a tray right here, filled with liquid resin. And your building platform lowers itself all the way down into the tank, and on the top of the tank surface, let me close this because I got resin in there, and get a different tank. These tanks are consumables, considered consumables, because they have the bottom right here is made out of a silicone layer, which is called a PDMS layer. And this silicone layer is important to make this machine work in first place. Now most of us, or some of us, know that nothing sticks to silicone. You can take a piece of tape, stick it on there, it's not going to stick. So using this is actually a smart choice for this technology. As the building platform lowers itself into the resin, it will go all the way down to the surface of the PDMS layer. And right in between those two, the resin is being cured. Laser coming through from the bottom and starts curing the first layer onto the building platform. And then, once that cycle is finished, you have to disconnect the tank from the building platform. Now, all of us who have used suction cups and played with them, if you stick them onto a surface and you pull them off straight, you got to pull quite a bit to get them off. And the same problem we have here, once the layers cure and you have those two surfaces on top of each other trying to be separated, you have the same force like a suction cup. Now, in order to minimize that, if you lift just one end of the suction cup, air comes in and it loosens off real easily. And the same idea is being incorporated here in the Form 1 Plus. They have a hinge on this side, and the tank will slowly tilt off into one direction, trying to just peel off the cured resin from the silicone surface. Now, while this is a slick idea, it still causes many problems because you will have a force in there no matter what. As the building platform keeps going up, increment by increment, you have, for every layer, you have this peeling action. It really goes like this. So every time this thing has to peel, there's a chance of a failure, of the part getting stuck to it, being ripped off the supports, being ripped off the building platform, and so on and so on. So to minimize that force, you have this peeling action and it's just pulling the building platform straight up, but also in the software you have the option of rotating a part. Now I have a pair of scissors here. If you look at those straight down, you have a fairly big cross section. Now if you were to build this straight onto the building platform like that, the tank would have to separate this large cross section. And in order to help minimizing that force, you can rotate the part so the cross section becomes much smaller than looking straight on. Let me demonstrate with the software. This is our demonstration model. I used scissors just for the heck of it. And if you load it up straight from your file, STL file, you get something like this. The box right here shows the area which the machine can build parts in. On the right, there's a little lever that shows us, if we move it up, what the cross sections for each layer look like. It also counts the layers. So layer 1 would do this, next layer, and so on. So we're going up, 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 up. You can see all the different cross sections that start forming during the building process, and suddenly we get something like this. This is a fairly large cross section to deal with. So at this point in time, our peeling force is at its greatest. And possible that this would be too much for the machine to handle, and suddenly it'll rip off your part and it gets stuck on the silicone layer. Not necessarily, not all the time, but it will happen. Everybody who uses this machine for sure will encounter that problem. So in order to avoid that from the very beginning, we go to our menu to the left, and here the second one gives us the option of orientation. If we click that button, it will start rotating the part and try to find suitable positions that minimize cross sections, like this, for example. If you have a little bit of experience with the program and how to turn them, you can rotate that whole thing by hand right into a position that you like this, like into a position that you feel is suitable. If we look at the cross sections now, you notice right away that they're much smaller. This is about the largest section we have, and then it gets smaller, 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 and to the very tip. Good position right here to minimize cross-section, therefore peeling force. In addition to the peeling force, we also have a problem with buildability. The easiest, I don't have anything around, like let's say this flashlight right here, would be a very simple shape, actually a perfect shape to build. If you start from the bottom, it would always build upon itself. As soon as you have this sticking out like that, suddenly if the machine would come to that spot, this would be in mid-air. Nothing would support this. Now let me show you using the software. As you see here, we have the glass. It's sitting on the building platform. We see it starts over the ring, first layer, and then it just simply straightforward builds upon itself layer by layer. It's very simple. It's a very sure way of building something successfully. Not all parts are that simple, obviously, but this is a perfect part when it comes to buildability. Now if we just add a stupid looking handle like that, everything changes. If we test our layer sections now, the handle starts building right there in mid-air, and without any support from the bottom up where it can build off of, it's going to cause a failure, which will eventually get stuck on the silicone layer of the tank, and depending on how big that area is, it'll keep just blocking the laser and cause damage to the silicone layer right there prematurely. If we were to build it upside down again, rotate it 180 degrees, then our chances of this becoming a successful part increase once again, as we now have a connection point right here off the rim for the handle, where the handle can literally grow right out of. So it's not going to start just in mid-air and cause a failure. This way, turning it 180 degrees back around again, our rotation has helped us making the buildability of this part 100% and therefore a success again. If you still wanted to build it from the original position, from the bottom up, it still can be done, but in that case we need to generate supports. Base position, and in order to do that, we need something that comes off of the base to the handle right here, where the handle can grow out of, so it doesn't just start creating in midair and floating away from our spot here. Now let's go to our supports, and if you're starting out, I'm just going to touch on that briefly, but if you're starting out, I would recommend just use the default setting here, and you also have a possibility for hollow spaces to generate right here, to generate supports inside these hollow spaces. Sometimes you have ceilings or curved walls that would otherwise collapse. Let's generate them real fast. Here they are. First you get the base, and now from the base the supports come out, and then of course the ring of the bottom of the glass starts forming first, and then right here you have the spot where finally our handle can grow out of safely, basically, and then eventually attach to the top of the glass. That's perfect. The machine is basically fighting three elements: peeling force, which we're trying to counter by eliminating a large cross section due to rotation; buildability, which also can be changed due to rotation or helped by support. So we have the support structure, we have the peeling force, and we have the buildability factor that all needs to come into one when building these parts. The software cannot find a perfect precision, especially if you have a complicated part. There'll never be a perfect precision, but it's always going to be a good compromise of all of the three in order for your part to be successful. Optical path. Okay, very important. You basically have 4 mirrors in this machine. You got your 2 galvanometers. Those are the 2 little mirrors that guide the laser, and then the I don't know what they're called, the guide mirrors that guide the laser to your tank. The big one in the front and the small one right below the galvanometer. So you got 4 mirrors. They need to be clean. Most of the time you'll have a problem with the big mirror. If you don't pay attention, you have some resin dripping on there, or just dust accumulation, and this needs to be cleaned at all times. And also we must not forget the tank, which is a big problem. If it fogs up, the laser can't get through, and after, I don't know, it really depends. I have not been able to push more than 1 liter through one tank, and then it was all the tanks, I have 5 tanks now, that were so damaged that you cannot use them anymore. The parts fail just because of the worn out tank. So this is very crucial to make sure your tank is clean. Also, particles in the tank, if a piece gets stuck in the tank and so on, you got to clean those out of the tank, and I'll show you how to do that. I happen to have a tank here that just comes off a failure, and I need to strain the resin, which brings me to another problem. For some reason the machine off and on cures small particles within the resin that are not part of your model. This is a problem. So if you have little cured particles in there, or pieces stuck on your tank, first of all, you have to get those pieces out. You have to find them. I think I got those out already. You take the spatula right there, the putty knife that is being supplied with your machine, and you go through the tank, see if there's anything in there, and a larger part that you can pick up right away, and you just go and grab that with the with your tweezers that also come with your machine. So now it really doesn't matter. I mean, the tank needs to be strained. I need to get every particle that might be in there out. I can't really tell if there's any in there. Typically, I just use a container, clean, fairly clean, and pour the entire amount of resin into that container. Clean up your tank. You don't want to have anything stuck on the outside of the tank. You can scrape out the rest if you want to. If you have a container like this, the sharp edge, I like to just scrape it into the container. It's not much, but at least, you know, some stuff you can still save. All the rest we just have to scrape out. And this is a little bit of a messy deal, but we got to get everything out so we can start new. And what we need now is a paint strainer, something like this. They're not expensive. You can get those at any car part place, Craigan's, whatever's out there. I don't even know. But I think they have those. Any company that sells paint should have it too. Sherwin-Williams. Just get a box of these guys. They're not that expensive. And you will need them. All you do is you just put that thing over here and pour your resin right back into it. And it'll strain all the problems out of this resin. Okay, and once everything is through, you're good to go. And you probably, it's probably hard to see. The tank is good to go, new resin, and make sure your lid is clean before you put it back on there. There's no dust on it. Worst case scenario, if you're not sure, you take a piece of tape. And just cover your tank again. And you're ready for the next run. On my first machine, my laser actually went out. And don't make the mistake in believing just because you have a failed part that your laser is out. Only if the laser stops curing resin altogether, it's a problem with the laser. Of course, it's a rare occurrence because this machine is upgraded with a new laser system. It's a second generation, and you know, a lot of other little things they changed and upgraded here. As long as you find cured resin in your tank or on your building platform, your laser is still good. Now in my case, as I said, I didn't have any cured resin on the building platform after 2 hours of building a part, and also there was nothing inside the tank. So what I did to make sure it is the laser, I took the back out and took the laser out and held it into a puddle of resin. Had it run for a couple cycles and it wouldn't cure anything at all. The laser point was just so weak, so that was a part failure in my machine. It's very rare with the new machines, you know, who knows what caused it. Let me show you how to get to the galvanometers and how to clean those. What you need is a 2.5mm Allen wrench. Most of us have that at home. And there are, how many are there? Six screws that you need to take off. The two ones here on the side, center ones, two ones on top right here, and then there are two on the bottom, which I can get to like this, but I'll just hang the machine over. If you have a machine that has these two screws, you already have a newer model. The old model didn't have these two screws, so that's a good upgrade right here to keep that back plate in place properly. And just gently loosen this off on the side. Don't need any force. Pop this back plate out, so like that. So here's this is the heart of the machine. Here's our laser, and here are the two galvanometers right there. These are the two mirrors. You see the tiny little guys right here. Maybe I have to zoom in a little bit. And if they're dirty, you're in trouble. To get this thing out, you have to unplug each of the three components, which is simple. You take the cable of your laser right here, find that. This is a double cable. You reach in, just gently pull, grab this guy right here. It's sitting on there pretty tightly. And just wiggle it out. Same here. Memorize. It's not hard to memorize, right? Where which cable goes, so you don't mix up the mirrors in the end. And then you come back in with your Allen wrench. It's simply important. These two screws up here. This one and this one below. These two. Don't take anything off here. If you take this off, your laser is going to be out of adjustment. The first machine that I had was not keyed as well as this unit. See, this unit is keyed really well. Cleaning the unit and those mirrors, Formlabs has a pretty slick idea. They use a Q-tips like this, and then they want you to cut a piece about this size from one of those pads right here. Again, peg pads. Tape it around this Q-tip right here, using a piece of tape like about here. So I guess turning it away from this way into the tape. Tape it. I'll grab another piece that I have over here and secure that one more time. And this is your little cleaning device for the mirrors. A little bit of Windex right on here. And then, yeah, I see a smudge in there. I don't know how well I can place it so you guys can see that. You probably can't, but there's a smudge right on this back mirror right there. Before we put it in, I would recommend using a vacuum and draw out any dust that might still be in there. Simply line these guys back up in there. No force really needed. Plug these guys back in first again. Make sure you put this in the right way. Tangle this a little bit so there's no stress on it. Okay, this guy goes in the top. Probably like this, yes. Also, these are also keyed, these plugs, so it's easy to put on. Okay, and your unit is back in place. It's really very simple. The back plate on there. This way. No, I was right this way. Now, of course, if you have to clean some residue, some really serious stuff on your large mirror right here, you just do the same thing. You use take your peg pad, fold it up, and just go inside with a little bit of alcohol first to loosen up the hard layers if there are any on it, and finalize with Windex, which I would recommend. Use your gloves for that, because in here you gotta keep everything clean. Okay, that's about it on the most basic but important aspects of this machine. I hope it was helpful. If you have any questions, ask me, leave a comment below. I'll answer them. Thanks for watching.